So the first relationship that we're going to study today is that of a 45, 45, 90 triangle. And then we'll focus in on the 30, 60, 90 triangle, both of which we studied last year in Accelerated Geo. In the first diagram that you see here, we see that we are given the legs of a 45, 45, 90 triangle are congruent. And to get from the length of a leg of a 45, 45, 90 triangle to the hypotenuse, we would multiply by a factor of radical 2, which you see given there. So let's go ahead and try our first example. In our first example, we are given that one leg of a 45, 45, 90 triangle is given to be 45 centimeters long. How long are the other two sides? So given that this is a 45, 45, 90 triangle, we would know that the legs are congruent to each other. So therefore, these are, I'm going to switch colors to show that our assumption, therefore, is that we would know that the other leg is 45 centimeters and that our hypotenuse would therefore be 45 times radical 2 centimeters long. In our second example, we see that we are given, and I'm going to go ahead and change the colors, that we are given this time the hypotenuse of a 45, 45, 90 triangle. And so on that hypotenuse, we're given that it's 10 centimeters long. And the question is, what is the length of each one of the legs? Well, the hypotenuse is always the longest side length of a triangle. So if I am going backwards to get from the hypotenuse to the leg, what I would be doing is instead of multiplying by radical 2, I'd be dividing by the factor of radical 2. Our answer always must be presented in rationalized form. So therefore, we would want to make sure that we're multiplying the top and the bottom by radical 2 to rationalize the bottom, and basically essentially to get rid of the radical on the bottom. So we get an answer of 10 rad 2 over 2. We see that the 10 and the 2, you can, I just want to go ahead and point out that this part, you guys make sure that you can, if you can reduce, that you do go ahead and reduce. And so my final answer should be 5 radical 2. And the units of measure is centimeters. Okay, on our next example, we now move on to the relationship between a 30, 60, 90 triangle. So if we know that this angle right here is 30 degrees and that this is a right angle, our presumption would then be that this angle measured down in the corner is 60 degrees. And so it's written above here, the relationship, but I'm going to go ahead and mark it out here. Across from the 30-degree angle would be your shortest side. And so let's say that our shortest side is S as given here. BC equals S. I'm going to go ahead and call this S. That's my shortest side. And to get from the shortest side to the hypotenuse, you would double the length of your shortest side to get 2S. And lastly, to get from your shortest side to your medium leg, which is directly across from your 60-degree angle, you would multiply by a factor of radical 3. I always tell my students, you remember the radical 3 because there's a 30-degree. It's just something silly you can think of to remember the factor, as opposed to over here with the 45, 45, 90 triangle, you're multiplying by radical 2, which there's two 45-degree angles to help you remember that. Okay, so now let's go ahead and I'm going to erase what I have here. oops, that's not the eraser. Let me go ahead and erase what I have here. And in my first example, I'm given that Q has a length, let's go ahead and switch colors, has a length equal to 8. And so here we see we are given the shortest side and asked for the medium side and the hypotenuse. So this is what I'm asked for in the first example, in example number 3. Okay, and so if I'm going from the shortest to the longest side, which happens to be the hypotenuse, I would double the length of the shortest side and get 16. If I'm going from the shortest side to the medium side, I would go ahead and multiply by that factor of radical 3. Remember, 30 degrees 3. So 8 radical 3 would be the length of my medium side. So I'm going to go ahead and transfer those answers, 16 being n, and then 8 radical 3 being the length of p. Now, on example number 4, they are giving me the measures of n. And so let's go ahead and erase. And we are now on example 4. And on example 4, we're given what n is equal to, and we're asked to figure out what p and q are equal to. So in this picture, we're given, go ahead and use purple here, n is equal to 20. So we're given that, and we're asked to find the highlighted, the p and the q, the legs of the triangle. And so if I am going from the hypotenuse, or not basically given the short side, what I want to do is make sure I find the shortest side. Okay, and to get from the hypotenuse to the shortest side, I would, rather than multiplying, divide by a factor of 2 and get a value of 10. And now from the shortest side, so again, the order I went is hypotenuse to the shortest side. And to get from the shortest side to the medium side, I would multiply by, again, that factor of radical 3. And again, think of 33. Okay, so Q now we have is 10, and P is 10 radical 3. Okay, for our example on 5, I'm going to go ahead and erase here what was given on the previous problem. And this time what I want to do is work on question 5. And on question 5, they're giving me P and they want me to find N and Q. And so on this example, you are given 4 radical 3 is the medium side. And so anytime you're given anything that is not the shortest side, you're going to want to go back to the shortest side. And so if we remember correctly, to get from the short side to the medium, we multiply by radical 3. So we're going to want to undo that by dividing by radical 3. So when I do so, I get an answer of 4. And now to go from the shortest side to the hypotenuse, I'm going to remember that it differs by a factor of 2. So that is equal to 8. And so my answer, therefore, would be Q is 4 and N is 8. Okay, so let's go ahead and erase what we have from the previous example. And I am going to now highlight the question that we're on. Let's go ahead and move it so we see that question. P is equal to 6, and now we're trying to solve for N and Q. And once again, we are given the medium side is equal to 6, but this time you'll notice that you don't see the radical 3. So you're given the medium side, and if you remember from what we talked about earlier, you're always going to want to divide to get back to the shortest side. And if we remember the factor correctly, that's dividing by radical 3. This time you don't have a radical 3 to cancel out. So what you're going to want to make sure you do is, remember, we can't have a radical at the bottom, so we're going to rationalize that by multiplying by radical 3 over radical 3. So let's go ahead and multiply that through. We then see that the 6 on the outside of the radical reduces with the 3. So therefore, our answer for Q is 2 radical 3. Okay, and once we get Q, we can always get to our hypotenuse by doubling. So that would then give me 2 radical 3. Now sometimes you're given problems as a description. This one's a great one right here, where you guys are given an equilateral triangle. Let's see how much you guys remember from last year. An equilateral triangle. I know this comes up in AP Calc where the kids have to remember how to find the area of an equilateral triangle. And so for this one, we are given the altitude. Remember, you can drop the altitude down. That's the height of the shape in which you form a 90-degree angle as you do that. The altitude given to you is 15 degrees. 15 feet. If we remember correctly from last year, in an equilateral triangle, you have 60-degree angles for all three. That's how it adds up to 180. All the sides are equal, all the angles are equal. And so we then know that this angle is 60. So when we drop that altitude, we effectively made a 30, 60, 90 triangle. So if we know that the altitude is 15 feet, we are given the length of the medium side. And so remember, we always want to go back to the shortest side, which let me highlight for you right here. This would be the length of the shortest side. So to get from your medium side to your shortest side, what we want to then do is divide by that factor of radical 3. So once we divide by radical 3, we realize, well, we can't have that radical on the bottom, so we're going to rationalize. And so we end up with 5 radical 3 being the length of half of the base. So here I'm going to go ahead and draw an arrow. That highlighted piece is 5 rad 3. Well, it wants me to find the length of the entire side of the equilateral triangle. So if I go ahead and show you guys the entire length, I'm going to go ahead and highlight it in red down below there. It is twice the length of the yellow highlighted portion. So what we would then do is double that value. And so our answer, go ahead and do it in red, would be 10 radical 3. Okay, so that was the question. We answered the question, 10 radical 3. Let's go ahead and shift over to the next and last example. On this next and last example, we are given that the diagonal of a square. So if we think square, let's go ahead and make a square. Okay, that's the best square I can draw right now. You have that the diagonal length of the square is 6. And the question is, what is the perimeter of the square? Okay, so if we remember, a square is composed of 2 isosceles right triangles. So you have a right triangle here, a right triangle there, which if these sides are equal, we therefore have this is 45 and this is 45. So we know the length of the hypotenuse of the 45, 45, 90 triangle, and we are trying to go backwards, and I'm going to go ahead and switch colors. They are asking us for the perimeter. In order to figure out the perimeter, we would need to know the side length. And so going from the hypotenuse to the side length would require us to divide by a factor of radical 2, in which I have to rationalize. And in doing so, I get an answer of 3 radical 2. So the length of one of the sides is 3 radical 2. If I'm asked for the perimeter would therefore be equal to one of the side lengths times 4, since it's a square. And that would get me 12 radical 2. And so that completes the lesson for 30, 60, 90 and 45, 45, 90